Assalamu alaikum. Today our experiment is capacitor measurement. Means aim of this experiment is to measure capacitance of different capacitors. Okay, you will be given 4 or 5 capacitors and you have to measure. But before taking measurement, I mean to say before taking reading, we have to write the type of that capacitor and also the marked value of this. Okay, marked value means here you have to write, look at this, the type of capacitor. Type means there are two types of capacitor. Number one, electrolytic. Number two is non-electrolytic. Electrolytic means polarized. Another type is unpolarized, that is non-electrolytic. So first you have to write the type. After that you have to write its value, capacitance. Okay, marked value without measuring. It's marked, it's written on the capacitor. You can see some numbers, coding are given. You can write that capacitance, from that also voltage reading and tolerance. After that we will use LCR meter, this meter, to measure the capacitance. So we will start with first writing the type of this capacitor. Again, we know that there are two types. Number one, electrolytic. Okay. Number two, non-electrolytic. So first we will write the type. How to check, how to identify whether your capacitor is electrolytic or non-electrolytic. Look, we have different capacitors here. We'll check one by one. For example, this capacitor. So first you have to look at the sign, negative sign, here on the capacitor. Here you can see negative sign is marked. Can you see? Here negative sign is marked. Generally negative sign is marked, positive sign is not given. If negative sign is there, that means this capacitor is polarized. That means one terminal is negative, another one is positive. Okay. Also, negative lead will be shorter in comparison with positive lead. Okay. Also, this capacitor. If you look at this capacitor, you can see the negative sign is marked and also arrow is given. You know that. What does it mean? Arrow is on this side. What does it mean? This side is negative. Arrow is on this side. So this side is negative and this side is positive. Okay. But for non-electrolytic capacitor, negative positive signs are not given. If you check this type of capacitor, okay, negative or positive, nothing is marked. Also both the leads are of same size, also in this capacitor. Okay, there is no positive negative sign. So you have to check first if negative positive sign is given, that is polarized, means electrolytic. If positive negative sign is not given, that is non-electrolytic, means unpolarized. This one is also unpolarized. There is no negative positive sign is given. Okay. So first thing you have to write the type of capacitor. There are only two types of this, electrolytic and non-electrolytic only. Okay. So you have to write this type, electrolytic or non-electrolytic. Now we will start measuring capacitance. We will take different capacitors one by one. First, I am taking this one. Okay, as I explained, we have to check the type. Here negative sign is marked. Okay, so looking at this, I can say that this one is electrolytic. Okay, this side is negative because arrow is pointing towards this. So first of all, I will write here the type, electrolytic. Okay, this is the type. I am writing here electrolytic. Now, capacitance. For electrolytic capacitor, writing marked value is very simple and very easy. You know why? Because everything is marked on that capacitor. Everything is written and it is written with unit. So from the unit you can understand which number is voltage rating, which number is for capacitance, etc. Here you can see it is written 25V, that is voltage rating 25 volt. 47 microfarad, so the value of capacitance is given with unit, and also it is written M. M is for tolerance, right? We know that different values of tolerance. I can show you here also. Look, the different values. If it is F, tolerance is plus or minus 1%. If it is G, tolerance is 2%, J plus or minus 5, K plus or minus 10, and M is for 20. Generally for electrolytic, the value of tolerance is 20. So now I'll write the value. What is the capacitance here? Capacitance was given here 47 microfarad. Okay, it is written with unit. So I will write here 47 microfarad. Voltage rating was 25 volt. It is written with unit. And for tolerance it is written M. So for M it's plus or minus 20. So marked value is done. For any electrolytic capacitor, everything is given with unit. So writing marked value is not a big deal for you. Okay, it's simple. Now what we will do? We will connect this capacitor here in LCR meter. Right? We have to be careful. We have to connect positive with positive and negative with negative. For electrolytic, for non-electrolytic, no problem. You can connect either way. So I will connect that. Okay. Now before that I will switch it on. Means this LCR meter. You know that the name of this is LCR meter. That means it can measure L, inductance, C, capacitance, or R, resistance. Okay. So you have to check first the mode of this. If it is not L, you have to adjust using this button. This is LCR mode button. Where to check? You have to check here. On left hand side, the number is given. Okay. Here it is given. If it is L, now it is L. That means that this LCR meter cannot measure capacitance. Okay, so you have to push this button to change the mode. Okay, if it is R, again you have to push. But now for us, it's okay, it's C here. That means now this LCR meter is ready to measure our capacitance. Okay, it will give you the value with unit always on right hand side. The unit will be there. Okay, now I will connect this. If you are not using wire, you can insert this directly in this rectangular gap. But be careful, connect positive with positive and negative with negative. Now you can read here. What is the value? 48.99 microfarad. So you have to write this value in the table. 48.99 microfarad. You have to write this value with unit. So here I am going to write the value. 48.99 microfarad. Okay. After that you can check the value here. This value is 47 microfarad, and our marked value and measured value, these are almost similar. Okay, that means this reading is correct. Now I will take another capacitor. Okay, I am taking this capacitor now. First I will check the type. Is it electrolytic or non-electrolytic? How to check? Just check negative sign. This is not marked. So there is no negative mark. That means this one is unpolarized. Okay, or non-electrolytic. So here I will write the type of this. Non-electrolytic. Now capacitance. Here the numbers are given. What is given here? Here it is given only this thing 0.22K400. No unit. Nothing is written. Nothing is marked. Okay, 0.22K. So here first thing 0.22 is the capacitance. K is for tolerance. And last number 400, that is for voltage rating. So 0.22 is the capacitance. Now the question is, what is the unit of this reading? 0.22 is okay. But what is the unit? Unit is not given on non-electrolytic capacitor. We have to write. Okay. How to write? If this number is with decimal point. Okay. Number of this means this thing is given with decimal point, then the unit is microfarad. Okay. You know why? Number one, the value of this is always less than 1 microfarad. Okay. That means if it is without decimal point, the value will be more than 1 microfarad. It is not possible for non-electrolytic, because always for non-electrolytic value of capacitance is less than 1 microfarad. K is the tolerance. Tolerance K, we know that the value is plus or minus 10. And 400 is the voltage rating. Okay. Now what to do? Again, we have to connect this with LCR meter here. So we will connect this with LCR meter. So insert simply in this two leads. Okay, insert properly, it will give you the value. Now you can see the value is 215.9 nanofarad. So we can write here 215.9 nanofarad. If you convert nano to micro, it will be same. Or if you want to change here, you can change the range. Okay. But if you write 215.9 nanofarad, it's correct. You will not lose mark. And if you convert and if you check your reading, it will here in microfarad. If you convert this in microfarad, it will be same, almost same. You will get 0.215.9 microfarad. It's almost similar to this. Okay. Now we will take another capacitors. Now we will take another capacitor. This one. First again we will check the type. There is no negative positive sign is given. That means the type of this capacitor is non-electrolytic. So this one is non-electrolytic. Now the value. It is written on this. It is marked on this. The code is given. If it is not readable, I will show you. It is written here like this. 2G 104K. The value is written on this, or marked value is given by this code. Okay, for this capacitor. It's similar. 2G. 2G represents the voltage rating. And we know that the 2G code is for 400 volt. So first we will write the voltage rating for this. So voltage rating here is 400 volt. Now the value of this is again very important. 104 is the capacitance. 104. 3-digit number without decimal point. If there is a number without decimal point, 3-digit number, then the value is not 104, but the value is 10 multiplied by. You know why? Because here third digit represents the multiplier. So that is 10 raised to power 4. If third digit is 2, multiplier is 10 raised to power 2. So first 2 digit as it is here, the number 10. If it is 10 raised to 4, here it is 4, that means it's 10 raised to 4. And second most important thing is the unit. Unit of this is picofarad. It's not micro. You have to remember this. Unit is not given. Again, first 2-digit number is like this. If I change this number, if this number is not 104 and suppose this number is 242, the value will be 24 multiplied by this 10 raised to 2 and the unit is picofarad. Do you understand this? So we will write this value here in capacitance. The value will be 10 raised to 4. Don't forget to write unit picofarad. Also, this K, all of you know now. K is for tolerance, and if it is K, tolerance is 10. If it is J, tolerance is 5%, plus or minus 5. Now, okay, we have written tolerance here. Now we will measure capacitance. Okay, what to do? Just insert this here and measure. It will give you the value. Okay, the value is now 98.67 nanofarad. If you convert nanofarad to picofarad, it will be almost similar. Or if you convert this pico to nano, it will be 100 nanofarad. And you are getting here 98. So it's almost similar. Okay. Now we will take one more capacitor. This capacitor. Paper capacitor. It's very small in size. Generally on this type of capacitor only 3-digit number is given. That means only capacitance is given. Sometimes tolerance is given, sometimes voltage. But now on this capacitor only 3-digit number is written. It is written 271. And we know that if it is written 271 without decimal point, if it is without decimal point, that means the method of writing its value is, first you have to write 27. I'll show you here now. 27. What is this? This is not the value but the multiplier in the value of capacitance. So 27 multiplied by 10 raised to power 1. So 27 multiplied by 10 raised to power 1. And what is the unit? Picofarad. Same method we are using, what we have used for this. It was 104. So what we have written? 10 multiplied by 10 raised to 4. So here what we can write? 27 multiplied by 10 raised to 1. Or you can write 270. So this one is also a non-electrolytic. Okay, because there is no negative positive sign. And the number is written here 271, that is 27 multiplied by 10 raised to 1, that is picofarad. Let me remind you again, if 3-digit number is there, you have to write the unit pico. But if the value is given on non-electrolytic capacitor with decimal point, just like that, what is the unit? Microfarad. Okay, here picofarad. Now, again we will come back to this. On this capacitor, voltage rating is not given. So what we will write here? Nothing. Okay, if voltage rating is given, you can write. Tolerance, sometimes it is given, J or K. So you can write plus or minus 5% or 10%. And then insert this in LCR meter, it will give you the value. Okay. Sometimes it will give you the exact value. Sometimes some tolerance is there. Na? You will get value near marked value. That means it's correct. Okay. So that's all for this capacitor measurement experiment. Okay. Hope you understand. Thank you.